So what's happening in the heart is that we need the heart to beat in order, top, bottom, top, bottom. And there's actually going to be a little delay there because top, bottom. There's a little delay between those two words. And that delay is really important. It allows blood to actually move from the top to the bottom. It's not instantaneous, right? It's not like a light switch where the whoop, instantly it's on. There is a little bit of a delay. Mechanically, this blood's moving from the top to the bottom. And that delay is important. We're going to get into that in a minute. Electrically, we tell the top part of the heart to fire. Let me draw that giant heart again, right? And we know that we have a left and a right, a top and a bottom. This is left, this is right, this is an atria, that's an atria, this is a ventricle, this is a ventricle, right? Right atria, right ventricle, left atria, left ventricle. We know that there's a little electrical impulse that starts right about up in here, okay? And that electrical impulse is much like dropping a rock in a pond. If we drop a rock in a pond, we get ripples that come out just like this. You know, they sort of boop, 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 and they go out. And what's happening is when this little heart muscle cell here discharges, fires, contracts, depolarizes, uh-oh, big word. When it depolarizes, it causes all its neighbors to depolarize. And that causes all its neighbors to depolarize, and so on and so forth. But remember when I told you that these walls divided the heart not only in terms of blood, but also in terms of electricity? When these ripples bash up against the walls, they don't automatically travel to these other parts of the heart. They have to go through predetermined pathways. Think of it as you're on a highway, and the only ways on and off are on particular off-ramps. There might be exceptions, there might be deer, there might be weird things, but in reality, there's only one way on a highway and one way off a highway. If you miss that exit, you've got to go to the next one. Same idea. Well, there is one way that this signal jumps across to here. We don't talk about this too much, honestly. But there's a way that this signal travels down south here into the ventricles. All right? And I've drawn this very important idea. This sliding motion here up is very, very important. Okay? We're going to get to that later. But this pathway, this off-ramp, that allows the electrical signal to go from the atria down through the ventricle has a fancy name, and it's called the junction. In fact, because it goes from the atria to the ventricle, we call it the AV junction. It has other names, but for now, that's what I want you to stick with. When it goes through the junction, there's a little bit of a delay that allows blood to get from here to here. So we're talking about two concepts here. One is the electricity. That's one thing. And blood actually moving is another. Those are two separate things. In EKGs, we measure this. With blood pressure and measuring heart rate mechanically, we measure this. All right? Two different things. They are mostly related, but occasionally in sick people, they're not. So here, we're going from the top to the bottom. We're going through the junction, also called the AV node, or the junction. Okay? This electrical signal will hit a split. One's going to the left, one's going to the right. And these are called bundle branches. Or said a different way, we have a left bundle branch and a right bundle branch. One signal goes up here and starts the wave like this. The other one goes over here and does the wave like this. So rock in a pond, doop, 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 hits the junction, whoop, then goes back up like this. Atria, ventricle, atria, ventricle. And it's important because we're squeezing the blood out of the heart. We need the squeezing to be in order. If we don't squeeze everything in order, with each cell progressively grasping, can you see that? We're progressively grasping and squeezing like toothpaste out of a tube. We need it to go from the bottom to the top. Just like that. We need to go in a particular order to get the toothpaste out of the tube. If you squeeze at the top, the toothpaste, only a little come out, and all the rest of the energy is wasted. We need it all to be in order the right way. And that is a core concept in EKGs, that we need all the electrical signals to happen in the right order.